Welcome to math classes. Let's do some trigonometry functions critical questions. We have done the theory previously. Go through the previous video and the critical questions there, and we do some more critical questions from JEE and other competitive exams. Okay, this is mainly for class 11 and class 12. People who are interested in Maths Olympiad and advanced studies in 10th class, they can also go through this one. You can easily understand trigonometry. Okay, so before going into the critical problems, let's do some brush up of formulae. Okay, this is for the compound angles. Okay, you have some, if you want to reduce cos A plus B into a smaller components, this is how we'll do basically compound angles into. Okay, so cos A plus B is nothing but cos A cos B minus sin A sin B and similarly other things. Okay, but there are so many equations, how to remember, right? So if you see here cos A plus B, you have 2 cos, product of 2 cos minus product of 2 sines. Okay. And the cos A minus B, do you need to remember? Not required. Just replace B with plus B with minus B. So cos minus B is cos B, remains same. But sin minus B will become minus sin B. So the sign will become plus here. Okay. So you don't need to remember. This is very easy to understand. That once you know this one, cos A plus B, cos A minus B is very easy to understand. Similarly, sin A plus B, you remember, it is mix of sine, product of sine and cos and addition. Okay. So sin A minus B is obviously you will get a negative. That's it. Okay. So you just need to remember 2 equations, 1 and 3 out of this. And tan also, you just remember 5. That's enough. Okay. Cot, you don't need to remember. You can very easily derive this by replacing tan equal to 1 by cot or cot equal to 1 by tan. Okay. You can easily get this. Okay. These are very important to remember. Next. Yeah, this is another very important equation. Cos 2a, whenever you see cos 2a or other way, cos square a minus sin square a, you should replace with cos 2a and that will most of the times will give you answer. Okay, especially this equation. Okay, 2 cos square a, if you see, you replace with 1 plus cos 2a. 2 sin square a, if you see, you replace with 1 minus cos 2a. Okay, 1 plus cos 2a, 1 minus cos 2a. Okay, so these are very important equations. Most of the problems where you see cos 2a or 2 cos square a, 2 sin square a, you should replace with the other. Okay. Sin 2a, it's very easy. Just 2 sin a cos a, which is also equal to 2 tan a by 1 plus tan square a. Okay. Tan 2a is 2 tan a by 1 minus tan square a. You see the difference here, only the denominator sign is different. Okay. Next. Sin 3a, cos 3a, tan 3a. If once you remember the sin a plus b, cos a plus b, this is very easy to derive. So you don't need to remember. If you remember, it is very good. Okay, next. Yeah, this is another equation where addition of trigonometric ratios we are converting into products here. Okay, cos a plus b is 2 cos a plus b by 2, cos a minus b by 2. Similarly, all this. Okay. For understanding this more, you can watch my previous video, trigonometry class actually. That has more derivation and how to derive all this information is given. Yeah. So with this, let's, yeah, another last one. You need to remember these two values. Okay. You are not in 10th class now. That you should remember only up to 90, 0 to 90. You should remember more angles actually. Okay. You should understand sine 18, cos 18, and how to derive it. If you don't remember, at least you should know how to derive it quickly. So this is sine 18. Okay. This is cos 18 degrees. This is sine 36 degrees and cos 30 degrees. See the similarity and remember it well. Okay. Okay. Sine 18 is similar to cos 36. Sine cos 18 is similar to sine 36. So remember it. Okay. With this, we'll get into the problems. Let's say there is a question. This is one very good question. If sine of x plus 1 is not equal to 0, then the general solution of this one. Okay. The expression is numerator and denominator. You can see there is an infinite series. Of course, that is in GB, right? It is geometric progression. 1 minus sin x plus sin square x. So the common ratio is minus sin x in the numerator plus sin x in the denominator, which is equal to 1 minus cos 2x, 1 plus cos 2x. I told you just now, this is a simple GP equation, sum of GP terms. Always use 1 minus 2x equal to 2 sin square x, 1 plus 2x equal to 2 cos square x. This will solve the problems most of the times. Okay, so here RHS side you can replace with this. And LHS side what happens? 1 by 1 plus sin x because it is a by 1 minus r. Okay, r is minus sin x, so minus of minus r is 1 plus sin x. And divided by 1 by 1 plus 1 minus sin x, okay, which is equal to this. I am writing 2 sin square x by 2 cos square x. Okay, this is nothing but 2 cos square x. I am writing it as 1 minus sin square x. Okay, 2 and 2 gets cancelled. Now I am left with 1 minus sin x divided by 1 plus sin x equal to sin square x divided by 1 minus sin x into 1 plus sin x. I am just expanding this one. Okay, which means I am left with 1 minus sin x whole square equal to sin square x r. Okay, if I square root, I will get 1 minus 2 sin x equal to 0, r sin x equal to half, right? So simple replacement of this one has solved the problem for us. Okay, now sin x is half for pi by 6 and 5 pi by 6 in 0 to pi range. Okay, this once you should remember. So general solution will become every n pi, okay, every n pi minus 1 whole to the power of n, okay, pi by 6. This is the answer for general solution for this sin x equal to half. Okay. Let's say same question is asked, instead of asking for the general solutions, number of solutions of the equation within 0 to 75 pi. Okay. If question is like this, you will solve it same way. You will get sin x equal to half. Up to this point, it is same. And then sin x is half, we know, in the range of 0 to pi. Two solutions are possible. Okay. So if you draw the curve, actually, sine curve, okay, and you know that 0 is here, pi is here, 2 pi is here, okay, and your half value will come somewhere here, so it is intersecting at 2 points within 0 to pi, and pi to 2 pi, no solutions. So within 0 to 2 pi you have only two solutions, and that is actually from 0 to pi only. Pi to 0, pi to 2 pi, there is no solutions. Okay, so sin x has two solutions in 0 to 2 pi. How many 2 pi's are possible in up to 75 pi? 37 2 pi's are there, right? 37 into 2 pi is 74 pi. Okay. So 37 plus 74 pi and plus pi, right? So total you have is 37 into 2 plus 2, which is 76 solutions are possible. Okay. So this is how you should solve these problems. Uh, Hope you understand this one. Let's do the next. Next. Since we solved the problem with the graphs, actually, trigonometric graphs, let's understand trigonometric graphs. These are the important things to remember. Okay. So this should come into your mind how a sine graph and cos graph are defined. Okay. Sine graph, cos graph looks same. Okay. But very periodic and -1 to 1 ranges from. Only difference is at 0 degrees sine is 0. Okay. At 0 degrees sine is 1. Okay. So the waveform changes, shifts actually. Okay. By 90 degrees. That's the only difference. Otherwise, both the graphs look same. Now, if you draw a, let's say sine x equal to half, if you take, okay, so sin x equal to half in 0 to pi range itself, it has two solutions. This is important to remember. Whereas if you go to cos, okay, 0 to pi, it has only one solution. Okay, pi to 2 pi, it has another solution, which means it falls into one is this is 0 to 90. This is first quadrant. This is third quadrant. Fourth quadrant. Okay, so first quadrant and fourth quadrant, you will have solutions. Okay, whereas sin x equal to half, you will have in the first quadrant and second quadrant only have solution. So this is the difference. Just by 90 degrees shift, the solution can change like this. So this you should remember very well. And another thing you should know is area under half cycle is 2 units. Okay, this area under half cycle here, area under this is 2 units. Okay, this is very easy to prove using integration. I explained in my previous video. You can check it. Okay, once you know integration, you'll understand this very easy. Okay, similarly here, this half cycle is 2 units. Okay, now another graph is if I put sine graph and cos graph one by one, I mean overlap on each other. This is how it looks. Okay, the yellow one is sine graph, the blue one is cos graph. Okay, so they look like this. And let's say if you want to derive how much is the area between this sine x and cos x between this. Okay, this area if you want to check, that is very simple. Okay, you apply integration because this point is pi by 4, this point is 3 pi by 4. So you apply integration from pi by 4 to 3 pi by 4 sin x minus cos x. Okay, then you will get this is square root of 2 units. Okay, so this is how if the sine graph and cos graph are overlapped. Okay, this is how they look. This is important to remember these points. Okay, and the tangent and cotangent looks like this. You know that the tangent is not defined at 0, at 0, and cot is not defined at 1, at pi by 2, sorry. Okay, so at 0 it is not touching. If you see 0, it is not touching. At uh, pi also, at 3 pi by 2 it's not touching. Okay, so similarly at pi by 2 it's not touching. Okay, so this you should know, and similarly for the cot graph. Now secant and cosecant graphs looks like this, like a cups actually, either upward or downward. Okay, only difference you can see is for a secant at x-axis, basically it cuts the x-axis at 1. Okay, for yeah, secant, and cosecant doesn't cut the y-axis. Sorry, not x-axis, y-axis. Okay, so just remember this. Where it is 1, that is important to remember. Okay, uh, cosecant is 1 at pi by 2. So you can see here, graph comes like this. And the secant is 1 at either 0 or pi. So it comes like this. Pi it is -1. Now, how to draw this one? If some people are confused, it is very easy actually. You draw a sine wave. Okay, this is the first one is cosecant. Sorry, secant. So secant, you will draw a cos wave. Okay, cos is 1 at 0 degrees. Okay, and at 1, you basically you draw the cup upside. Okay, the curve upside. Okay, and at pi, cos is again -1. So here you draw downwards. Then upward. At 2 pi, it is upward. Similarly, for cosecant, you draw a sine wave first. Where sine is 1, you draw the graph. Okay, so this is how it looks if you overlap these graphs. Okay, hope you understand these graphs. These are very important to remember. You should know how a sine graph, cos graph, tan, cotan, secant, cosecant graphs looks and how they overlap each other. All these things are very important to remember. Let's see another problem. Okay, find the number of solutions of absolute cos x equal to cos x minus 2 sin x, okay, where x belongs to 0 to 10 pi. A range may be given anything, but you should know how to derive the values first. Okay, so one way of doing this is you can remove the absolute value by squaring it. Okay, but when you square it, be careful. You should substitute your value and see all values may not be correct. Okay, all solutions may not give you correct equation may not satisfy all solutions basically. Okay, so this is the squaring on both sides. What I will get is cos square x equal to cos square x plus 4 sin square x minus 4 sin x cos x. Cos square x gets cancelled. Okay, and I am left with sin x into sin x minus cos x, which is equal to 0. Okay, this gives me two solutions. One is sin x equal to 0, other one is tan x equal to 1. Okay, sin x equal to cos x, it will become sin x minus cos x equal to 0. So it will give me tan x equal to 1. Okay, obviously you can see one is applicable when cos x is positive, one is applicable when cos x is negative. Okay, but anyway, don't go by that. You first find out the general solution and then see which one is applicable. Okay, so sin x equal to 0 gives us general solution n pi basically, 0 pi, 2 pi up to 10 pi. Okay, but if you see, if you substitute 0 here, okay, if you substitute 0, you will get this equation is satisfied. But at pi, if you substitute pi value, cos x is -1, so but absolute cos x, which is 1, but here it is -1. Okay, so 1 is not equal to -1. So at pi, it is not applicable. Solution is not, this equation is not applicable at pi. Okay, which means I have only possible values are 0, 2 pi, 4 pi, 6 pi, 8 pi, and 10 pi, which is total of 6 values. Okay, similarly, tan x equal to 1 will give me general solution as pi by 4, 5 pi by 4, 9 pi by 4, up to 37 pi by 4. But the equation satisfies only for 5 pi by 4, 13 pi by 4, 37 pi by 4, these values. There are a total of 5 values. So total possible solutions are 6 plus 5, which is 11. Okay, be careful when you once you get the general solution, substitute and see. Okay, alternately, you can solve it. You take first cos x as positive, then cos x equal to cos x minus 2 sin x, then cos x gets cancelled, and sin x equal to 0. Now you know that cos x you assumed it as positive. Okay, so you make sure that you take only those values which are positive. Okay. So here cos x is positive at 0 or yeah 1, but cos x is not positive at pi. So don't take this value. Okay, 2 pi, yes, it is positive cos x, so you take it. That's what it is. Okay. And the second equation you will get is cos x equal to negative. So absolute cos x will become minus cos x equal to cos x minus 2 sin x. So again, you will get tan x equal to 1 only. But you know that cos x is negative. Okay? So where cos x is negative and tan x equal to 1. That is third quadrant. Right? So you take third quadrant values. Okay. So this is how you have to analyze the problem and do it. Let's see. Next. Yeah. Next problem. If sine square 10, sine 20 degrees, sine 40 degrees, sine 50 degrees into sine 70 degrees is equal to a minus 1 by 16 sine 10 degrees in this format. Then what is the value of 16 plus 1 by a? Okay. So yeah, before starting this one, we need to learn one another important, very important trigonometric formula. Okay. If you have sine 60 minus a into sine a into sine 60 plus a, then use this formula, okay, which is equal to 1 by 4 sine 3a. Okay, use this formula. This is very useful and this will help a lot actually. Okay, let's see the proof of this one before doing this problem. Okay, so okay, we know that 2 sin A sin B is equal to cos A minus B minus cos A plus B and cos 2A equal to 1 minus 2 sin square A. These two formulas we will use to solve this one. Okay, so sin 60 minus A sin 60 plus A sin A. Okay, I am rewriting this sin 60 minus A and sin 60 plus A. Okay, product, right? So into this one, so it will become half of cosine 2a minus cos of 120 degrees, okay, into sin a as is I am writing. Okay, so this will become half of cos 2a sin a minus cos of 90 plus 30 into sin a. Okay, so which is nothing but half of cos 2a sin a plus sin 30 sin a. Okay, now if I cos 2a, if I replace with 1 minus 2 sin square a, then what I am going to get is 3 sin a minus 4 sin cube a divided by 4, which is nothing but sin 3a by 4. Okay. So this is a very, very useful and important formula. Many questions are coming in JEE and BITSAT based on these formulas. Okay, this is about sine, right? Sine of 60 minus a, sine a, and sine 60 plus a. Okay, similarly, you have for cos also. Cos 60 minus a, cos 60 plus a is also equal to cos 3a divided by 4. Okay, so 60 is nothing but 5 by 3, you should remember. So it may come as in the radians also. Okay, and if I divide sin a by cos a, I'll get tan a. So for tan also you'll have a formula which is just simply tan 3a. Okay, 1 by 4 1 by 4 gets cancelled. Okay, so use this one appropriately. This is very, very useful and simplifying formula for your trigonometric equations. Okay, let's go back to the problem now. Okay, so now we know that this formula is there, so this is very simple, but just to make sure that how you are grouping. Okay, in this one you can find only sine 50, sine 70 and sine 10 which will follow in that in this formula, right? So you group them separately like this, okay, and then you have sine 10 degrees, sine 20 degrees and sine 40 degrees. So the first part will become sine 3 times 10 degrees, which is sine 30 degrees. So that is 1 by 2 we know, and 1/4 of that one. Okay, so this is 1 by 8, and then from the second part I am taking sine 10 degrees separate and sine 20 and sine 40. Okay, I am multiplying the numerator and denominator with a 2. Okay, so I am rewriting this. So finally I will get 1 by 16 into, okay, sine 10 into, and this one I am rewriting as this numerator part. I am rewriting as sine 20 degrees minus, sorry, cos 20 degrees minus cos 60 degrees. Okay, now we have very simple equation. You have to just apply sin A sin B, 2 sin A sin B and 2 sin A cos B. This is what we will apply because we will multiply here sin 10 degrees, cos 20 degrees, sin 10 degrees and cos 60 degrees. Okay, we basically use this formula. Okay, so 1 by 16 into this value, which if I simplify further, what I will get is 1 by 16 into sine 30 minus sine 10 degrees by 2. Okay, then minus sine 10 degrees. Okay, that is simplified further to 1/4, 1 by 16 into 1/4 minus sine 10 degrees. Okay, so which I am leaving it as in terms of sine 10 is there already, right? So I will leave it as it is 1 by 64 minus 1 by 64 minus sine 10 degrees divided by 16, which is in the form of a minus sine 10 degrees divided by 16. So a is equal to 1 by 64. Okay, so it's just a matter of uh, using this formula and solving this equation. Okay, now what is asked is 16 plus 1 by a, so which is nothing but 80. 16 plus 64 it will become, which is 80. Okay, Hope you can remember this formula. This problem is mainly meant for this understanding this formula. Okay, where to use, how to use. Okay, next. Okay, you have three more formulae to understand trigonometric series. Okay, last until few years back, only these formula application problems were coming only in the JEE advanced. But last 2 years we started getting in JEE mains also. Okay, so which means we should know this one. This is very simple. You have angle in arithmetic progression. Okay, angle a plus x, a plus 2x, a plus n minus 1x. Angles are in arithmetic progression, and trigonometric ratio, that is sine, is in the addition. Okay, not product. Okay, summation, which is equal to sine nx by 2 divided by sine x by 2 into sine of a plus n minus 1 by 2 into x. Okay, I'm sure this is easy to remember. Okay. Similarly, you have for cosine also. Cos a plus x plus cos a plus 2x up to cos a plus n minus 1x is nothing but exactly same. The initial value sine nx by 2 divided by sine x by 2. Instead of sine, you get cosine a plus n minus 1 by 2 into x. Once you start using, it is very easy to remember this one, and try to prove this equation. This is very interesting equation. I'm just leaving it for you. Okay. And another one is here, only for cosine you have this formula. Okay, so uh, cosines are in the product and geometric ratio. Okay, cosines product basically cos a, cos 2a, cos 2 square a, cos 2 to the power of n minus a. They are in the product, and the angle is in geometric progression. Okay, this is nothing but equal to sine 2a by 2 to the power of n sin a. I think very easy to remember. Okay, we will do one problem at least based on this one, then you will understand how to apply it. Very simple. Value of cos 2 pi by 7, 4 pi by 7, and 6 pi by 7, right? Cosine value of this. Okay, so you can see 2 pi by 7, we don't have any particular angle to remember those values, right? So what we will do is we'll apply this one cosine formula. Okay, a is 2 pi by 7, and x, which is difference, is also 2 pi by 7, and number of terms are 3. So if I apply this one, what I will get is sine, right? Sine 6 7 by 7 divided by sine 2 pi by 7 into cosine of 2 pi by 7 plus 2 pi by 7. Okay, so which is equal to sine 3 pi by 7. Oh, sorry, there is a divided by 2 also there here actually. Okay, there is a divided by 2 which I missed here. Let me write it here. Okay, so this will become sine 3 pi by 7 into sine pi by 7 into cos 4 pi by 7. Okay. Now you take the numerator, multiply with the numerator and denominator with 2. Then you can apply the formula here. Okay, right? This is sine and cosine, which is sine a plus b minus sine a minus b. Okay. So if you apply the sine pi minus sine pi by 7 divided by 2 sine pi by 7. Sine pi, we know it is 0. So this value will become minus half. Okay. So if you remember these formulae, trigonometric ratios, trigonometric equations, functions, these problems you will solve very, very easily. Okay. So do remember this. This will help a lot. Okay. Yeah. Next. Yeah. Next problem is the smallest positive value of x in degrees for which tan x plus 100 degrees is equal to tan of x plus 50 degrees into tan x into tan of x minus 50 degrees. Okay. If it is given 60 actually here, it should have been very easy. Correct? We can apply tan x plus 60 tan x into tan x minus 60. But it is not given as 60 here, it is 50. So let's take two of them to one side, two of them to other side and solve the problem. Okay. So tan x plus 100 degrees divided by tan x minus 50 degrees equal to tan x plus 50 into tan x. Okay. Now, I just convert this tan into sin by cos. Okay. And then this is, then I have sin x into cos x, right? Sin a into cos b. So I am converting into addition of two sines and subtraction of two sines here. Okay. So sin 2x plus 50 plus sin 150 divided by sin 2x plus 50 minus sin 150, which is equal to, on the RHS side also do this. Okay. Now I am applying reverse. These are the formulas I am using actually here. Okay, the reverse component and dividend form. Okay, what is component and dividend? We know if a by b is equal to c by d, which means a plus b divided by a minus b is equal to c plus d divided by c minus d. What I'm trying to do is I'm applying, if this is in this form, so I will convert it to the initial form, that is a by b equal to c by d. So if I see here, a plus b divided by a minus b. Okay, here also, if I rewrite this into this form, a plus b divided by a minus b. Okay, so my component of dividend says it is equal to a by b equal to c by d. So a is sine 2x plus 50 divided by sine 150, which is equal to, from this form I will get cos 50 minus cos 50, okay, divided by minus cos 2x plus 50, which is nothing but, so I'll get minus cos 50 degrees divided by cos 2x plus 50 degrees. Okay, hope you are clear till this point. Okay, now you have very simple equation here, and out of that also, out of this also, sine 150 we know is nothing but sine 90 plus 60. Sine 90 plus 60 is cos 60. Cos 60 is 1 by 2. Okay, so if you take care of that value, then you are left with three trigonometric functions. Okay, so you rewrite this in this equation, cos 50 degrees plus 2 sine 2x plus 50 degrees into cos 2x plus 50 degrees equal to 0. This is nothing but 2 sine a cos a, which is nothing but sine 2a. So cos 50 degrees plus sine 4x plus 100 degrees equal to 0. Okay, now this is I'm just taking 90 off. Okay, complementary angle, right? So it will gets converted into cos. Okay, so sum of two cosines. Sum of two cosines, I will write it in the form of 2 cos 2x plus 30 into cos 2x minus 20 equal to 0. Okay, now this is the equation where we can stop because we got our answer already. Okay, this means that one of this cosine has to be 0 or both of them. Correct? Only then this equation will be true. So very simple, you equate them. Cos of 2x plus 30 equal to 0, or cos of 2x minus 20 equal to 0. And the question asked is smallest positive value of x. So we should check always in the first quadrant only. Okay, 2x plus 30 and 2x minus 20 are in the first quadrant. So which means 2x cos is 0 at 90 degrees. So 2x plus 30 equal to 90 or 2x minus 20 is equal to 90 degrees. So you will get your x value as 30 degrees or 55 degrees. This is the answer. Okay. Yeah. Next. Evaluate sigma k equal to 1 to 7 tan square k pi by 16. Okay. These are the very basic questions which comes in any competitive exam or your boards actually, 11th and 12th boards. Okay. Always first thing in trigonometry you should see is if there are any of such problems you have complementary or supplementary angles. That is most important thing. Here if you see pi by 16 and 7 pi by 16 are complementary, right? The angles dealing here we can be grouped into complementary angles. How can we do? Pi by 16 plus 7 by 16 is pi by 2. 2 pi by 16 plus 6 pi by 16 is pi by 2 and other one. Okay. Remaining angle is 4 pi by 16 which is nothing but pi by 4. So you already have tan pi by 4 which is 1. Okay. So and we know that tan of pi by 2 minus a equal to cot a. So here the given expression will become, if I group them, tan square pi by 16 plus cot square pi by 16 plus tan square 2 pi by 16 cot square 2 pi by 16 and so on. And this value we know it is 1. Okay. Now what we will apply is tan square a plus cot square a equal to 4 cosecant square 2a minus 2. Okay. You can easily derive this one. You just expand into sine and cos format and see. You can easily do this yourself. Okay. This is not a big thing. So once you substitute these values, the given expression will become 4 times cosecant square 2 pi by 16 plus cosecant square 4 by 16, which is nothing but pi by 4. So you have the value for this already, plus cosecant square 6 pi by 16. So you are now left with only two cosecants. Okay. So 4 times cosecant square 2 pi by 16 plus cosecant square 6 pi by 16 plus 3. Okay. Make sure that your whatever numericals you are converting trigonometric ratio into number, make sure that it is properly added or subtracted. Okay. Now, once you know this one, you are here at this step. We simplified to the most of the extent, and 2 pi by 16 and 6 pi by 16 are also complementary angles. Okay, so this you can cosecant square 6 pi by 16 you can write in terms of secant square, right? Right. Once you have it in secant square, either you can, if you are sharp, you can actually solve it here itself. Otherwise, you convert it to sines and cosines and then deal with that. What you will get is 1 by sine square 2 pi by 16, cos square 2 pi by 16. Of course, the coefficient and the addition constant will be already there. Okay. So this is nothing but uh, sine 2 pi, right? Sine 2 pi equation. If I take multiply with 4 on both sides, You'll get, so 16 times 1 by sine square 4 pi by 60 plus 6 plus 3. This is nothing but 5 by 4. So you have already have the value 1 by 2 square. So it is 1 by 2. So what I will get is 2 into 16, that is 32 plus 3, which is 35. So given summation is 35. Okay. So these are very common problems which comes in JEE or any engineering entrance exams. So uh, keep solving these problems. You will understand how to do them, how to group them, how to find out complementary, supplementary angles, how to find the equation formulas. You'll remember. You have to solve more and more problems only. Okay, that is the only way to remember all these equations. Otherwise, you'll never remember these equations. And if you don't know the equations, you can't try solving there. Okay, remembering these equations will help you a lot. Okay, once you know the equation, every problem is really 1 minute or 2 minutes. If you don't know the equation, then you will take half an hour. Okay, you can't solve it. Okay, let's go next. If 2 cos x plus sin x equal to 1, then what are the sum of all possible solutions of 7 cos x plus 6 sin x? Okay. First thing we should say, if we can easily convert this into 7 cos x plus 6 sin x, so it doesn't look like it is possible. So best way is convert cos x or sin x into only one of the trigonometric ratio. Okay, either into cos x or into sin x. That should easily help us. Once you know one of this, let's say I know sin of x, sin x, then cos x I can derive very easily, right? 1 minus sin x by 2. Okay, so let's do that. How can we do that? 2 cos x plus sin x equal to 1. I'll take sin x to the other side. So 2 cos x equal to 1 minus sin x. I'll square on both sides. Okay. 4 cos square x equal to 1 minus sin x whole square. I'll expand it. This is the what. And then I know that cos square x is nothing but 1 minus sin square x. Correct. So 4 minus 4 sin square x. And simplify it. I get a quadratic equation in sin x. 5 sin square x minus 2 sin x minus 3 equal to 0, which is nothing but sin x is equal to, if I apply the quadratic equation formula, 2 plus or minus square root of 64, that is 8 divided by 10, which is nothing but 1 or minus 3 by 5. It looks like both values are valid. Okay, for sin x, both are valid. So we will take one by one. Let's case 1. Sin x equal to 1, then cos x equal to 0, obvious, right? So once you know this one, 7 cos x plus 6 sin x equal to 6. This is one solution. Okay. Second value, for sin x equal to minus 3 by 5, either you can calculate cos x by sin square x plus cos square x equal to 1, or you know sin x is minus 3 by 5. So minus 3 by 5, if I substitute here, cos x will become 1 plus 3 by 5 divided by 2. 1 plus 3 by 5 divided by 2. Cos x, which is nothing but 4 by 5. Now I know these two values. So 7 cos x plus 6 sin x is nothing but 2. This is second solution. Now he's asking sum of all possible solutions. There are only two possible solutions. So answer is 6 plus 2, which is 8. Okay. Yeah. Next. If sigma of r equal to 1 to 13 of this expression is equal to a root 3 plus b in this form, okay, then a comma belongs to z, then what is the value of a square plus b square? Okay. So look at this one. The problem looks very complicated, but it is easy. Okay. Look at the denominator here. The difference in angle is pi by 6. And the sine of pi by 6, you have a value already. Correct? Which is 1 by 2. So normally, if you get such in fractions, sigma functions in fractions, what you will do is you will try to take the numerator 1 and try to make it a minus b, which is, if it is 1 by a by 1 by ab, then we try to make it a minus b by ab. Correct? We will try to do same thing here. Okay. So difference in angles of denominator is just pi by 6, which we have lucky actually. Right? So this one, I will rewrite it as sine of difference in both the angles. Okay, is pi by 6, right? Sine pi by 4 plus r pi by 6 minus pi by 4 plus r minus 1 pi by 6. Okay, the difference is pi by 6. So I added in the numerator sine pi by 6 here. So I'm dividing with sine pi by 6. Simple. Okay, sigma remains same. Everything remains same. Now this is nothing but sine of a minus b. Correct? So I apply sine of a minus b formula here and expand it to sine of sine and cos minus cos and sine. Basically, sine A cos B minus cos A sine B. Denominator remains same. Now, if I divide this each term, you see there is a common term in each one. Okay, sine of pi by 4 plus r pi by 6 is common here. So it gets cancelled and you get a cot theta here. And in this term, the sine of pi by 4 plus r minus 1 pi by 6 is common. So this gets cancelled. and you will get a cot pi by 4 plus r pi by 6. Now it is very simple. So this is 2 times because pi by 6 is 1 by 2. So 1 by 1 by 2 is 2. 2 times sigma cot of pi by 4 plus r minus 1 pi by 6 minus cot of pi by 4 plus r pi by 6. Now you expand it very easy. 2 times cot pi by 4 when r equal to 1 minus cot pi by 4 plus pi by 6. When r equal to 2, it is cot pi by 4 minus something. So, and it goes on, last term is this one. Okay. And you know that second term, third term gets cancelled. Okay. Fourth term, fifth term will get cancelled, and you are left with only first and last terms, which is 2 times cot of pi by 4 minus cot of pi by 4 plus 13 pi by 6. 13 pi by 6, you can write it as 2 pi plus pi by 6. So you will basically get cot of pi by 4 plus pi by 6. You can expand and find the value, which is nothing but 2 minus root 3. And cot pi by 4 is 1. So if you substitute these values, you will get in the form of 2 root 3 minus 2, which is in the form of a root 3 plus b. So a is 2, b is 2. So a square plus b square equal to 8. This is the answer. Okay. So most of the things you do in fractions and algebra, number theory, all those they will try to give questions in trigonometry, similar questions. Okay. So all those will help you here. If you have solved sigma problems in algebra, fractions and all, that will help a lot here actually. Okay. Equations, all those if you solve. Okay. Yeah. Next. Find the sum of all positive solutions of 2 cos x times cos 2x minus cos 2014 pi square by x, okay, which is equal to cos 4x minus 1. Okay. You can see cos 4x here, okay, which is nothing but cos 2a form. So I will substitute it into 2 cos square a minus 1. Okay, that is the first thing I was always telling. So this is the first step. Okay, now expand it. 2 cos square 2x minus 2 cos x into cos 2014 pi square by x equal to 2 cos square 2x minus. Okay, now 2 cos square 2x is common, so cancel it. I am left with very simple equation cos 2x into cos 2014 pi square by x equal to 1. Now we know that it is product of two cos ratios equal to 1, which means both have to be 1 or both have to be minus 1. These are the only two options which we have. Otherwise, the equation will not be satisfied. So both should be either 1 or both are minus 1. Now let's take case 1. Both are 1. So cos 2x equal to 1, which means 2x equal to even pi basically, that is 2k pi, or x equal to k pi. K belongs to natural number. Okay. This is first. Once you know x equal to k pi, you substitute here. This should be even pi, right? This should be even pi. So 2014 pi square by k pi, which is nothing but 2014 pi by k. Okay. For this to be even, okay, we need to find out factors of 2014 and then how we can keep it even, right? 2014 is nothing but 2 into 19 into 53. 19 and 53 are primes. So these are the values you have. So k has to be other than, you cannot cancel the even number, right? It has to be even, right? So you cannot cancel 2. K cannot be 2 or k cannot be even. So k is equal to 1 possible, 19 possible, 53 possible, 19 into 53. These are the four values possible for the k. Okay. So which means x is equal to pi, 19 pi, 53 pi and 1000 pi. Okay. These are the possible values of x. Now let's take the case 2. Both are minus 1. So cos 2x equal to minus 1 or 2x equal to k pi. K can be any natural number. Okay. So x is equal to k pi by 2. Okay. K is odd integer. That's the only possible solution. Otherwise, you will get plus 1. Okay. So now you know x value is already there, k pi by 2. You substitute it 2014 pi square by k pi by 2, which is equal to 2 into 2014 pi by k. This should be odd pi. Only then you have solution. Okay. How we can get odd pi? Okay. What are the possible values? Okay. So this should be odd, which means this is possible only if k is equal to 4, because 2014 has 1, 2. 2 into 19 into 53, this should go up, and 2. So k has to be 4. If k is 4, if k is 4, this will become 2 pi. X will become 2 pi, right? So that is not possible. If k is 4, it's not possible because k has to be odd. Only then it is solution is possible. So from case 2, we don't get any solution. So only answer left is sum of all solutions we have to do. Sum of all this one is 1080 pi. Okay. So these are the sum of all solutions. Okay. Yeah, that's all. These are the critical problems which I want to take. Most of them are already came in JEE Advanced or Mains. Mostly I am choosing Mains actually. Advanced I am not touching too much. I will go as I do more and more videos and more lessons. I will add more and more chapters. All the problems I will hopefully by end of this year I will have complete JEE videos with all critical problems here. So I hope this will be useful for uh, 2026 engineering entrance takers. Okay, this I'm trying to make it helpful for them. I will try to cover all the problems. Already you have around 300 plus videos. So even if I count one video as one problem, you have close to 400 problems already there from 2, 3 chapters. So I will keep adding more. Okay, keep doing math till then. Thank you.